Hello viewers, in today's class we are going to take up one more important form of integration, and here we will learn how to integrate uh, a function like this, right? So here the function is given as 1 over px plus q times square root of ax square plus bx plus c, right? So here we see that px plus q is a linear factor, and inside the square root sign we have the quadratic function, right? So here we have to integrate 1 over a linear factor times square root of a quadratic function, right? So L is the linear factor of this form px plus q, and q is the quadratic factor, right? So let us start. So here we have one problem, and here we have the linear factor as x plus 1 and the quadratic factor as x square plus 4x plus 2, right? So now here again we'll take the help of substitution method, right? So let us take x plus 1 is equal to 1 over t, right? So what we will do here, we'll take the linear factor, which is px plus q is equal to 1 over t. So whatever is the linear factor, we have to assume it as 1 over t. So we are changing the variable x to t, right? So once we have assumed this, now we are not going to differentiate it directly as we have done in other questions, right? So what we will do, we'll take the logarithm of both sides, right? So before differentiating it both sides, we'll first take the logarithm of both sides. So we'll have log of x plus 1 is equal to log of 1 over t, right? So this is log of x plus 1 is equal to minus log t, right? Because log 1 over t is log t raised to minus 1, and we have minus 1 times log t, right? Okay, so we have log x plus 1 is equal to minus log t. Now we will differentiate both sides, right? So if we differentiate both sides, then we'll have 1 over x plus 1 dx, and here we have minus 1 over t dt, right? So differentiating both sides, we have 1 over x plus 1 dx minus 1 over t dt, because the derivative of log function is 1 over x, right? So we have 1 over x. Okay, so now we have this result. See, here we have dx over x plus 1 is equal to minus dt over t, and here we easily see that we have the factor dx over x plus 1. So for this dx over x plus 1 will replace it by minus dt over t. So this is the significance of this type of substitution, right? Okay, so now so this is our first step, that is the step of substitution here, and the second step is to take care of this quadratic function. So here we have the quadratic term, that is x square plus 4x plus 2, and we have to now express this quadratic term in terms of t, right? But before doing this, let us make it a perfect square, right? So we can now write it as x plus 2 whole square because we have x square, then we have 2 square is 4 and 2ab term is 4x. So here we have 2 square, that is 4. So to compensate it, we have to subtract 2, right? Okay. So now we have x plus 2 whole square minus 2, and now we have to express it in terms of t, right? So from this relation, we have x is equal to 1 over t minus 1, right? So now if we take x equal to 1 over t minus 1 over here, then we have 1 over t minus 1 plus 2 whole square minus 2, right? Now we can simplify it. So we have 1 over t, 2 minus 1 is plus 1, whole square minus 2. Now we can write it as 1 plus t whole square over t square minus 2, right? And we can further write it as 1 plus t square minus 2t square over t square, right? Now here we have a square, and now if we expand 1 plus t square whole square, here we'll have only t, then we have 1 square, that is 1 plus t square plus 2t, and here we have minus 2t square over t square, right? And now this t square minus 2t square is minus t square, right, over t square. Now see, here we have the quadratic term in t, right? Now again, what we will do, will express it in terms of a perfect square, or we'll write it like this: 1 minus t square minus 2t, right? So this expression can be written like this, because 1 minus t square and minus minus plus, so we have 2t, right? Now again, we can write this term t square minus 2t as t minus 1 whole square. So we have t square, then minus 2ab term is minus 2t, and then we have plus 1, that is 1 square, which is 1. So to compensate it, we have to subtract 1, right? And in the denominator we have t square, right? Now taking this negative sign inside this bracket, we have 1 minus t minus 1 square plus 1 and over t square, right? So now 1 plus 1 is 2, and we have 2 minus t minus 1 whole square over t square, right? And this can further be written as square root of 2 square minus t minus 1 square over t square, right? So viewers, let us summarize it quickly. So what we have done, we have here we have adopted two steps. The first one is we have substituted x plus 1 is equal to 1 over t, taking logarithm and differentiating, we get this expression. And then in the second step, we have taken the quadratic factor, and we have expressed this quadratic factor as this factor, right? Okay, now let us substitute, or let us rewrite this integral as. So now for this dx over x plus 1, we have here minus dt over t, and for square root of x square plus 4x plus 2, we have this term. So we have square root, then we have root 2 square minus t minus 1 square over t square, right? Now taking this t square outside the integral sign and taking it to the numerator, we have t, and we have square root of root 2 square minus t minus 1 square, and here we have minus dt over t, right? And this t get cancelled, so now we are left with taking this negative sign outside the integral sign, so we have minus, here we have dt over square root of root 2 square minus t minus 1 square, right? So now viewers, we have this integral and we have reduced this integral to this form, and now let us again substitute here y is equal to t minus 1, so therefore dy is equal to dt, and I becomes negative of dy. For dt we have dy, and here we have square root of root 2 square minus y square, right? Okay, so now we have a very simple integral here, because we know that the integral of dx over square root of a square minus x square is equal to sine inverse x over a, right? So this is the standard integral, and if we compare, then this integral resembles with this one, and here a is equal to root 2, right? So I is equal to minus sine inverse y over root 2, and c is the constant of integration, right? Okay, now we can express this result in terms of t. So we have I is equal to minus sine inverse, for y we have t minus 1 over root 2 plus c, and again we have to express this t in terms of x, because we have assumed x plus 1 is equal to 1 over t, and x is equal to sorry, here we have t is equal to 1 over x plus 1, right? So we have minus sine inverse, and for t we have 1 over x plus 1 minus 1 over square root of 2 plus c, and this is sine inverse. Here we have negative sign, and we have 1 minus x minus 1 over x plus 1 times square root of 2 plus c. So this one and this one get cancelled, and we are left with minus sine inverse minus x over x plus 1 times root 2 plus c, right? So this is the required integral of this function, right? Now viewers, there is an interesting fact here. We can also express this result in terms of cosine inverse function, right? So for this we'll make use of the result from inverse trigonometric function, which says that sine inverse theta plus cos inverse theta is equal to pi over 2, right? So here if we take theta is equal to minus x over x plus 1 root 2, then sine inverse theta can be written as pi over 2 minus cos inverse theta, right? So now here we have I is equal to minus sine inverse theta plus c, because we have assumed minus x over x plus 1 times square root of 2 as theta, right? So I can be written as minus, for sine inverse theta we have pi over 2 minus cos inverse theta plus c, and this is minus pi over 2 plus cos inverse theta plus c. And we can easily see that minus pi by 2 plus c is some other constant, let us say it k. So we can now write it as cos inverse theta plus k, where k is some other constant of integration which is equal to minus pi by 2 plus c. And now we can resubstitute the value of theta here. So we have minus x over x plus 1 times square root of 2 plus k, right? So this is another expression for this integral.